To our ancestors, the sky and earth, humans and gods, and animals and plants were all interconnected elements of a single, interactive environment. The sun, moon, and stars supplied heat and light, enabling living beings to flourish. Their consistent patterns of movement and transformation allowed them to serve as natural compasses, clocks, and calendars. The perceived usefulness of the stars and planets varied across different regions of the ancient world. Inhabitants near large rivers, such as the Euphrates and the Nile in the Middle East, were more affected by rain and river levels than by seasonal changes. Conversely, in coastal areas, variations in temperature and daylight had a greater impact on human, animal, and plant life. Critical hunting and gathering seasons were governed by a solar calendar, as the sun's movement was understood to drive the cycle of spring, summer, fall, and winter. This immense importance led people to believe that the sun needed to be observed and worshipped. The significance of the moon. Around 10,000 years ago, during Mesolithic times, many people lived near water. In coastal regions, they observed that tides were particularly high or low at certain times of the month, corresponding with lunar phases. These tides, now known as spring and neap tides, influenced fishing, shell collecting, and transportation opportunities. The full moon, serving as a night light, impacted daily life, much like the hours of daylight dictated daily tasks. Their days were marked by sunrise, noon, and sunset, with activities guided by both solar and lunar calendars. Identifying patterns. Long time ago, people observing the phases of the moon noticed a regular pattern recurring every 15, 30, 44, 59, and 74 days. The interval between successive full moons, 29.5 days, became well known, establishing the concept that would eventually be called a month. Notably, the positions of celestial bodies are predictable. Both the sun and the moon consistently rise in the east at regular times. Unlike the unpredictability of weather and human relationships, the sky is reliable. Observers soon realized that the time between one midsummer and the next was 365 days. Employing the sun as a timekeeper. At midsummer, the sun reaches its highest point in the noon sky outside the tropics, and at midwinter, 183 days later, it reaches its lowest. The idea of using the sun's movement as a clock began with observing how shadows cast by objects like a vertical stick or an obelisk, a tall, thin stone, point toward the western horizon at sunrise and due north at noon. Every hour, the shadow moves further around, functioning as a sundial. Similarly, most stars traverse the sky, and an imagined line from northern stars to the celestial pole acts like the hands of a gigantic clock. Early astronomical advances took place in Babylon and Greece around 700 BCE, driven by planetary astrology. It was believed that the positions of planets, the sun, moon, and stars, and the timing of their risings and settings influenced life on Earth and foretold the future. Accurate observations of planetary positions were recorded on Babylonian clay tablets to predict future movements. In Greece, Hipparchus aimed to improve these measurements by documenting the position and brightness of around 1,000 major stars, leading to the development of spherical trigonometry and the adoption of the degree as a unit of angle. By the 2nd century CE, the Greek astronomer Ptolemy had divided the Mediterranean sky into 48 constellations in his renowned treatise, Almagest. His precise drawings, still useful today, helped detect the movement of stars previously thought to be fixed. Angles that had once been estimated using an extended hand were now carefully measured with an adjustable cross staff or celestial compass. Planetary motions. The future movements of the planets were predicted using complex geocentric models, where planets moved at constant velocities around a series of theoretical circles. In the 6th century BCE, the Greek astronomer Pythagoras proposed that the Earth was spherical. In the 3rd century BCE, Aristarchus argued that the Earth revolved around the Sun, though this theory was not widely accepted at the time. Aristarchus also used precise eclipse timings to calculate that the moon was about 60 Earth radii away, a value accurate within 1% of today's measurement. Around the same period, Eratosthenes accurately measured the Earth's radius and the tilt of its spin axis. Marking time. Time was measured during the day using the sun's shadow, and sundials became commonplace. At night, people relied on stellar positions and used primitive water clocks, sandglasses, and candle clocks to keep track of time. This was important for performing prayers at specific times of the day. Religious observance also required close observation of the moon and the sun. Once major religions were established, many societies used both lunar and solar calendars to accurately set festival dates. Even today, the Christian festival of Easter is set on the first Sunday after the first full moon following the spring equinox. Calculating the year. The length of the tropical year, the time interval between successive equinoxes, was estimated by observing the daily lengths of noontime shadows. The year's length could also be determined by measuring the time taken for the Earth to orbit the Sun, using fixed stars to track the movement. The dawn rising of stars like Sirius or star groups such as the Pleiades was used for this purpose. A significant breakthrough occurred when the Greek astronomer Meton, born circa 460 BCE, discovered that 19 solar years were nearly equivalent in length to 235 lunar months, known as the Metonic cycle. This cycle was used to set the dates of religious festivals and predict solar and lunar eclipses. The Julian calendar was introduced by the Roman Emperor Julius Caesar in 45 BCE, defining the year as 365.25 days long, with a leap year added every 4 years. This system had an inaccuracy of only 1 day every 128 years, which was corrected by Pope Gregory XIII in 1582 CE. The lunar calendar, with its month of 29.5 days, does not align well with the solar calendar, which has a year of 365.25 days. Chinese astronomy had developed independently since the 12th century BCE, with detailed maps of the constellations showing their extensive knowledge of the night sky. The Astrolabe. The elevation of the sun was used to measure the latitudes of locations on Earth. This technique was crucial in Islam for determining the direction of Mecca, which led to the development of the astrolabe. The astrolabe, an instrument used to measure time and position, was developed by Abu Ishaq Ibrahim al-Zarqali around 1015 CE. If the latitude was known, the altitudes of the sun or specific stars could be used to determine the time. Conversely, if the time was known, the positions of the sun and stars could be used to establish the latitude. Much of the information presented in this video comes from the enlightening book Science, the Definitive Visual Guide by D.K. To delve deeper into the fascinating world of the first astronomers and their groundbreaking inventions, please find the book link in the description below. Thank you for watching. Your support is incredibly valuable to us. Please like, share, and subscribe to stay updated with our latest content. Follow us on YouTube, Rumble, Instagram, Facebook, and TikTok for more exciting updates and insights.